G'day, g'day, g'day. Just a quick one tonight. I'm at the workbench and I thought I might as well be streaming, because why not? Now that we're set up, I might as well just go live anytime I can. I'll give you guys well, all you guys that watch this channel, you'll get a super sneak peek of what's coming up. So what I'm thinking is I have a video coming up on these, the ESP32 board, I think it's called the Wemos ESP32 Lite. They're designed for Python, for MicroPython, I think was the original intent, but last night and today I was able to program it with the Arduino IDE no problem, and this is a pretty cool project. I've already started the GitHub repo, so what I'm going to do is I've got these thermocouples, the MAX6675, basically just an amplifier, I think, with this high temp thermocouple, and we're going to take this and either one or two of them, hook the ESP32 up, and then we'll have this create its own web page that we can log on with our smartphone and look at this thermocouple temperature. On top of that, I'm going to add a what is it, the BME 280, not the BMP 280, the E, and I'm going to interface that as well, and I'm going to use it for temperature, pressure, and humidity. And that will live in the enclosure with this, and this thermocouple we're going to stick wherever we want in an internal combustion engine. And primarily I'm going to use it first for tuning chainsaws. And you guys who follow me on Make Me Outdoors, you've seen I have lots of saws and I put them to work here and there, and nowhere have I ever seen anyone anywhere create an engine monitoring system to do the tuning for a chainsaw. So I thought that might be super cool. For, like, there's no real need, it's overkill. Anybody tuning a 2-cycle engine can set carb mixture just fine, but why not actually be able to measure it? And the saw guys might just appreciate that, the performance guys, and you can also use it for any engine. We'll just stick that in the exhaust, or you could stick it with to the side of a cylinder or the top of a cylinder head. There are lots of things we could use it for. And why is that sticking? And just use it for an impromptu performance monitor for tuning or whatever. I think that'll be just awesome. What I'll do is I'll set up the web page so that it graphs over time, that you can see all the different points, and hopefully have an export function would be awesome, and be able to save the data locally as a data set. Either that, or I could always add a micro SD card. But this ESP32 should be way overkill, but the reason I selected this is because it's the only board I currently have that has onboard battery management for a Lipo battery, for a one cell battery. I may use the Lipo, or I may even try like a couple of AA's or something. I'm not sure. I've never played with it, but a single cell Lipo obviously is what this is designed for, and seems to work fine. So there we go. All soldered up, and here's a Lipo. This is programmed up with the code I've been just playing with the thermocouple code. This is the right battery, right? Yeah, that's the right connector. There. And it doesn't look like I set up any LED functionality. I don't think I did on this with this code, but yeah, it should work. Then over here, we grab one of these. I should be able to see if that battery's charging. I don't remember the last time I charged that battery. And we are squat. But I would imagine that thing's probably charged. Yeah, we have a charge indicator, 0.06 amps, so 6 milliamps. That's nothing. It must be charged. But yeah, seems to be working fine. Cool. That should be a-okay. So what we'll do is just figure out, I've put these connections deliberately the wrong way so I can just stuff this into the board and not have it come way off the top and put stress on the pins on the board while I prototype this. So what I'll do is, like, we can just stuff it like so. Actually, what I'll do is we'll just move everything down the board. Okay. And move this right down to the end where we can USB it easily. Connections on both sides. I don't think I've done much with this board, breadboarding yet. So we'll just stuff that in like so. Our connections are labeled on the front side. Ground, VCC, serial clock, chip select, and SO. What is SO on SPI? Serial clock, chip select. There's always that one set that has like 3 different acronyms for it. I never remember. It's okay. I'll figure it out when I look at the code. We need some wires. We'll wire this up. This is going to be a fun little project. Why do you do this? Stick. My camera is trying to grow legs here. There. That should be a little bit more stable for you. Let's find some jump balls. We just need male-to-male jumpers. A few different colors would be handy. We need 5, right? Yes, 5. 5 would be a good start. What color do I not have? Orange. Can I has orange? Orange. That'll do. That ought to get us going. And then what I'll do is get this prototyped, and get this working, and then we will go to adding the BME. I ordered the BME 280s from China just today, and then I also ordered 1 unit from my local Amazon because I really want to get this project underway. I think this is going to be a lot of fun. This is a neat project. I'm pretty happy with the idea, and I haven't found anyone anywhere that has done it. So I like doing projects that no one has done before. VCC, let's use red. What VCC would this be? Let's try 3.3. Seeing as how this is a 3.3 board. This should be, that's 3 volts. This is a new board to me, so I have to look everything up. I'll double check, but that is labeled as 3 volt out. We'll see. And then our serial clock, chip select, and SO. So I don't know what each of those are on this board. I gotta go check. I have a GitHub repo where I saved all the reference material for this board. You guys haven't seen it yet because the video hasn't gone live. I haven't finished editing it, but you can see in my GitHub all the info that when I was playing with these in MicroPython. I was pretty happy with them, and I got more of them. These, I really love the little form factor. It's like a Wemos D1 Mini with most things broken out, except with battery control on it, which is seemingly kind of rare. I can't seem to find many, so there. That should work to prototype. I just got to figure out what pins to plug things into. And I've already tested the code without this plugged in, and it's working. Initially, when I had the pins wrong, it caused basically a kernel panic of the CPU. It caused it to go bananas and just spew all this garbage out on the serial port. But when I changed the serial pins just a few minutes ago, or not serial pins, when I changed the pins from the default Adafruit sketch for their library over to what I think might be close for this board. Again, it was a guess. There's nothing hooked to it, so there should be no harm. It seemed to calm down, and then it's reading through serial, just not reading an actual temperature, because there's nothing. It's just coming back as zeros. So, yeah, this should be good. Right on. I think we're in good shape. Alright, guys. Just wanted to go live for a minute and hang out with you guys. A little bit of fun. Hope you guys are having a good week, and good luck in all your projects.